Now, another quantitative comparison strategy. First, I'll point out that after the math content modules, we will have a module on advanced quantitative comparison strategies, in which we will discuss how different content areas show up in the quantitative comparison questions. In that module, I can talk about all kinds of strategies that are specific to various content regions. But of course, we haven't talked about any of those content regions yet. So this is just one general trick. It's a quick trick we can use in a variety of quantitative comparison questions. For now, I will simply call this trick matching operations. So what do I mean by this? Well, in any quantitative comparison, we're trying to determine the relationship between two quantities. We could say that between the two quantities, there's an unknown relationship, either the greater than or less than or equal or cannot be determined because it's a combination of one of those. It's important to recognize that there are mathematical steps we might take to simplify the problem that do not change this underlying relationship. In particular, the three legitimate steps that we can do: we could add the same number to both quantities. That wouldn't change the relationship. We could subtract the same number from both quantities. That wouldn't change the relationship. Or we could multiply or divide by the same positive number. Multiply by the same positive number or divide by the same positive number in both quantities. So all three of those are simplification moves that we can do because they don't actually change the underlying relationship. Now, why we can do these steps and not others, for example, multiplying or dividing by a negative, we'll discuss that in the advanced videos after we've discussed all the math content. Don't worry about that right now. Right now, simply practice this as a strategy because when you're used to thinking this way, this strategy can enormously simplify many quantitative comparison questions. Here's a practice problem. Pause the video and then we'll talk about this. Okay, so we're comparing two fractions here. In particular, notice that both of those fractions are between 4 and 5. In other words, in each case, the numerator is greater than 4 times the denominator and less than 5 times the denominator. That's interesting. So they're relatively close in value. Well, one thing we can do, just to make them smaller, is we can subtract 4 from both quantities. And in particular, I'll subtract 4 and put it in a form with a common denominator, so that would be the same as subtracting 32 over 8 from quantity A and subtracting 12 over 3 from quantity B. And that leaves us with much simpler fractions to compare. Well, now, once we have those, we can find a common denominator. Now again, if all this stuff about fractions and finding a common denominator, if you're not familiar with this or not comfortable with this, don't worry. We will have full lessons on fractions coming up very soon. Just go with it right now. We'll find the common denominators and we find that quantity A is bigger. So the point is, by subtracting from both quantities, we made the comparison much easier. Here's a practice problem. Pause the video and then we'll talk about this. So many people get stymied by this kind of problem. They start picking numbers. They say, well, what happens if I plug in 4? What happens if I plug in 5? And in fact, that kind of approach is really a trap answer for this question. Instead, it's a good idea whenever there are x's in both quantities to try and simplify so that you only have one x. It's sort of similar to if you have an equation and you try and isolate x. You try to solve for x. So I'm just going to subtract 3 from both quantities. Then I'm going to subtract x from both quantities. Then I'm going to divide by 2. And so now I see that I'm comparing x to 3.5. That's really the comparison here. And so what happens if x is bigger than 3? Well, again, if you're thinking only in terms of numbers you can count on your finger, x equals 4, x equals 5, x equals 6, all those would have to be bigger than 3.5. But we're not guaranteed that x is an integer here. Nothing in this problem is guaranteeing that x is an integer. So x could be a fraction. It could be a decimal. X could be pi, for example. Pi is bigger than 3, but pi is smaller than 3.5. 3.001 is bigger than 3, but it's smaller than 3.5. And in fact, 3.5 itself is bigger than 3. So x could equal 3.5 and the columns would be equal. So for different choices, quantity A could be bigger, or quantity B could be bigger, or they could be equal. We have a sometimes situation, so that right away means that the answer has to be D. Here's another practice problem. Pause the video and then we'll talk about this. So this one is a word problem, and this is starting to get into territory, this could be something that might show up on the GRE. So, machine A can produce 8 nails in 14 seconds, and machine B can produce 7 nails in 9 seconds. So these are rates. And so we want the time. So we have to set up fractions. So the time, if it takes 14 seconds to make 11 nails, each nail must be 14 elevenths of a second. And if it takes 9 seconds to produce 7 nails, each nail must be 9 sevenths of a second. So we're really comparing these two fractions. And so what I'm going to say is, let's just multiply. Let's multiply by 7. So on the right side, that's just going to be in quantity B, that's going to be the time it takes to produce 7 nails, which is going to be 9 seconds. And on the quantity A, we have that kind of ugly thing. I'm going to leave it in that form for the moment rather than multiply out. Now, multiply both sides by 11, so we don't have a denominator on either side. So on quantity B, we have 11 times 9. The 11s cancel. In quantity A, we get 7 times 14. Well, now we just have to do those multiplications. So you should be practicing mental math so that you can do these multiplications without touching a calculator. 7 times 14 is 98. 11 times 9 is 99. And 99 is bigger than 98. So quantity A is faster, quantity B takes more time, so the time it takes is larger, and B is the correct answer. In summary, one strategy we can use to simplify many quantitative comparison questions is matching operations. So the 3 things that we're allowed to do: we can add the same number, any number, to both quantities. We can subtract the same number, any number, from both quantities. And incidentally, because it's any number, we could also add or subtract any variable. That's also perfectly fine. Or we could multiply or divide both quantities by the same positive number. These operations preserve the underlying relationship between the quantities. This is not the only QC strategy. We will learn more in the later module when we get to the advanced QC strategy module, but this will give you a way to start some QC problems.